Okay, this is a video on how to make the jaw handle, and there's detailed steps on the slides as well as the dimensions. So here is the jaw handle, and how it's made. It's made of the first part, that's your jaw, which is actually same as from the lower jaw. Okay, and this is your metal part. So you have your metal, the real thing has the metal handle all the way to the bottom, but in modeling we only model the bare part of this metal, and coming down it's your grip. So there's a rubber grip outside of the metal handle. So for the model, we're gonna model this whole piece down here is your grip, and we use two swept for this metal part. We swept the outside shape of this metal part. Then we also swept the inside. Then use subject to cut this part. And for the handle, the grip, we also use swept, because this shape is kind of very hard to extrude or using other method. Okay, and well, you're welcome to use the method for the handle, which is all extruded, and you do edge blend, and it's gonna be a little bit off here, but that's fine. So this is also two swept. You have one swept for the outside, and the second swept to cut into this grip. And later on, for this part, it's gonna be an extrude. So you can extrude all the way to the bottom, then you do edge blend or chamfer, but chamfer will not give you this the same radius here. Okay, so I used a swept, and this is a very simple swept, so don't worry about that. Okay, so now let's start with the jaw and the metal parts. Probably this grip is gonna be in the second part of this video. Okay, so let's build a new file first. It's gonna be model, and just keep this name. You can rename that, and choose inch as your unit. So I'm looking at the slides, so I will follow the slides. So first, actually we don't need to build one. Okay, so first you want to open your lower jaw, and since these two, the left and right jaw, they are the same shape, you don't want to do that again. Okay, we can save as this file, save as, and you can say jaw handle or anything. So now we are in another file, and then NX just close that lower jaw file. So you can do all this will be our jaw handle. Okay, and if you notice, the geometry here is actually this cutter. Okay, on the lower jaw it's a blade, and here it's actually like a cutting board. It's flat here. So go back and modify this sketch. Okay, and apparently we will have this. Okay, we can keep this. We're gonna delete all the stuff that we don't need. That means this too. Okay, we don't need this little ear. Can delete, and we don't need that sketch also. Just delete that. And see what we have in the first sketch. Okay, for this sketch, you want to modify this sketch into the shape that's listed in the slides. So So wireframe and hide the extrude. Okay, maybe I can also hide this, hide the teeth. We don't really need to do anything for the teeth. Okay, and here we don't need this. We don't need either of these two circles, so we can delete all the stuff here. Alright, and if we look at the slides, the dimension of this point to that point, well, I need to delete this first. Well, it depends on your sketch really, so everyone has different sketches. And I'm gonna extend this curve first. Okay, so I just pick the x-axis as the boundary curve, and then we can extend this curve. Alright, so the length of this cutting board is, I don't know how much. I only know the height of this cutting board though. So I can use a curve to cut this and give this curve a dimension, which is 23 over 32. Okay, and we can use quick trim over this, then you can delete this curve. Okay, so we have this cutting board down, and we don't need this curve actually. Okay, delete this, and you're gonna keep this curve so the top can match to your lower jaw. And let's see, did I put any dimension there? I don't think so. Well, okay, let's measure from the yeah, it's gonna give me arrow. Doesn't matter. I'm gonna measure from this. Okay, show parents. Show parents. Okay, then this is our sketch, and okay, I have a tangent arc here all the way down, and what about the radius? The radius is (39 over 64). So you don't have to be the same as my shape, because everyone, I think this shape, everyone has different shape. Okay, so I'm gonna do this as my shape. 1 plus 39 over 64. So we're gonna use this 3 point, first point, and I don't know where is the second point. I just click anywhere and make it tangent. Well, I guess I don't really need to measure that. So make sure this point is tangent, and this point have some dimensions. We'll have a look from from this point to the origin is 31/64. Okay, close this reference. We don't want to use reference. Here to here, it's 31/64. Okay, and have drawn the line here, a horizontal line, put a dimension, the height of this line is 15/16. So that's gonna be the reference point here. We're gonna add one point here, but also we need to add one point first, and make sure you use intersection snap. Snap to the intersection, close, and we can make this line to reference. Okay, and let me add this dimension from this point to the center. In my geometry, it's 15/16. Okay, so you don't have to do this because the bottom part, they're gonna enter the metal part, so they're gonna bury it in that metal part, so this shape does not really matter that much. And to me, I want to make sure, well, let's finish this first. We'll come back and modify this. Okay, and yeah, the extrude gonna be screwed, but don't worry about that. Chamfer, we don't need that chamfer too. Unite, don't need this. Okay, that extrude, yeah, because I modified that. Modified this. Okay, I'll just stop, don't put this dimension now. Okay, keep everything as usual. Delete this, delete the unite, depends on what you have, and we can add the second datum coordinate system for the handles. Though the handle part, they're gonna be tilted. Okay, so come here, datum coordinate system, and I think it's gonna be, well, we need first we need a reference line for that datum system. So we need a sketch. Click sketch on y-x plane. I need to show the datum. First, the datum coordinate system. Okay, gonna be y-x plane. Click OK, and I will need a reference line. That's the direction of your handle. Okay, and turn that into a reference. Now we add constraints. We can use parallel dimension for this. The length is 5 plus 5/8. Okay, so now we can do the angle dimension. Is we can pick y direction, and this line, the angle here. Alright, actually I didn't want that. Well, so in a slide that's 8 degrees, so 180 minus 8 degrees, 172. Press enter, click OK, close. Okay. Now you have this reference line. You can put another reference dimension to remind yourself what this dimension is. So once you're done, you can change the style to fraction dimensions. It's gonna ring outside. 1/8, 1/64 accuracy. Okay. Alright, now we have the reference line. Then we can add the date and coordinate system. Okay. We can use orange, X and Y. Okay. X, Y. That means we need another reference line. So come back to the sketch. We need another line that's perpendicular to this. So we can have two axes when you pick the coordinate system. And we are done. Make this reference. The length doesn't matter. Finish sketch. And click here, date and coordinate system. We're gonna use orange, X and Y. So first specify the origin point. That's gonna be here. Okay, X. So our original X is here. We can pick this as your X, and we pick the point on Y-axis. Gonna be on this. We can pick this point. So you have Y-X, and click OK. Now we have the second date and coordinate system. So why do I want this? Well, the lower handle is tilted, and I think this point is, yeah, so this point is not that easy to find, huh? Okay, radius. Nope, I want this. I don't want a reference. I want a real one. Close. And go back to my draw handle. Measure the radius. That's 139.64. I'm trying to fix this 1 plus 39.64. I think that worked. Okay, it's still there, and it is still here. Okay, and also another line. So now it matches the shape in the slides. Okay, and let's have a look. Finish the sketch. A lot of warning. This extrude is weird. Okay, and once you double click that extrude, everything should be back. If not, we can, you can always deselect the curve and that's what I'm gonna do. Deselect, and let's try connected curve. Okay, so it's gonna be symmetric at 1/8. Click OK, and show it. Okay, so since we have cut. We have cuts here. You don't have to modify that already. So we have this and that. Now they're two different solid. We can unite them together, or we can just leave them alone. Okay, so this sketch, yeah, we don't really need. Okay. All right, so we are done with the jaw part. We can come down to the metal part, the metal handle. Okay, so if you look at the slides, the metal handle consists of 3 cross section and 2 guideline. So first we're gonna build 3 datum for your 3 cross sections. Okay, so the first datum gonna be at distance from your bottom of the handle. Try to pick this. Okay, invert. Oh, we should try that distance actually. So this one, raining outside, and the distance of this datum is 3.9375. Okay, it's on the slides. Apply. That's one datum. And the second datum is gonna be on the origin of your absolute coordinate system. So now we're gonna use the method will be point and the direction. So we need to specify a point that's gonna be orange. Okay, and the vector, we pick this reference line. So this datum gonna be normal to this reference line. And click apply. Okay, and you can have a look. They are perpendicular to your reference line. And the third one, let's cancel this first. Third one is gonna be on this point, the one we just add. Yeah. So what we do is we can turn this point to reference. Okay, hover and then quick pick. Turn this to reference. Or we can just leave this alone. But I like them to be reference, so they will not be modified. Okay, the third datum, it's again, it's gonna be point and their direction. Specify the point. It's gonna be this point. Okay, be very careful of picking. So end point. No, I don't want existing point. Okay, existing point. Pick this, and the direction is this one. Okay, and let's have a look first. Okay. All right, now we have 3 datums, and if you don't like the shape, you can move it around. And put the point back. Well, make it bigger. Okay. Yep. So here are our 3 datum. So next we're gonna draw 3 cross sections. So let's start from this one. Okay, sketch on plane. gonna be this, and we can, sorry about that, we can try to flip the direction of your coordinate system on the sketch, and try, well, by default it should be on this curve. Well, it doesn't matter really, you can just go ahead, proceed, and hide this, and I'm also gonna hide this. We're gonna leave them alone for a while. We can hide the two other datums. Okay, and then we can start, draw on this sketch. So Shift F8. Okay, if you press F8, look, it's tilted because our datum is not. It's not what you say? It's not X, Y, or Z principal planes on the absolute coordinate system. So we have to do this, and okay, let's see the dimension. The dimension is first it's a box-like shape. So basically we're gonna do, okay, we can maybe have a reference line. Okay, a reference line. Then we can start a box, because our box, the edge of the box is gonna go across this reference point, and Shift F8, box, 2-point box, about like this. Then we gave it some dimensions. The height is 7/16. The length is 1.75. Okay, and also we want this to be in the middle of your axis, so we can put another dimension from the top line to the center of orange, to sketch orange. We can put it as P255, which is this, the height of the shape divided by 2. Okay. Now you see everything is green. Alright, it's constrained. Okay, and next step is the we don't have to do the fillet right now. We can do the offset. So this is the outside of your metal part. We also needed to have another closed loop when you do another swept, so you can cut into this metal piece. So that's gonna be, we can use offset, and the metal part has a thickness of 3/32. That's the thickness of our sheet metal. So pick a curve. We can choose single curve because we don't want to pick the whole box. We can pick this one, that one, this one. So change the direction. Okay, and I think that's it. And click apply. Close this. And since we're gonna cut into this box, we can have this the inside loop to be somewhere outside, a little bit longer, sticking out from the outside box. So we have here, we can use quick extend, extend. Okay, So now we have two loops. One is the narrow one, and the other one is a box. Now we can do a fillet. So the fillet is 5/64, and we're gonna fillet this corner as well as this corner and this corner. And I'll try to click OK. Okay. Oh. It's 5/64. Here and here. This here and here. Okay. Close this and make sure the curve is right. So I think I just filleted here, filleted my reference line. So we need to trim away this excess line here, and my reference line apparently is buried behind this, and you can actually delete that. You don't really need that. Okay. Alright, so let's finish sketch. Now we have two loops, outside and inside. This is for the first swept sketch. Okay, and we can, since we are done here, we can hide this, and let's show the second sketch, second datum. Alright, the second datum is build the second datum, and you can use a flip. You can keep it like this. Click OK, and Shift F8. Alright, so second datum, the second one, we have you can love Florida. Second one, box. Okay, two box, the same thing, and go back to sketch. Another box. So here we use different approach, two box for two, close the loop, and the dimension. Height is the same, 7/16. Okay, and since we are here, we can put the. We can make sure this is center. P 262 divided by 2, enter. Okay, and then the width. Okay, so here we don't use width, we use here one edge to the orange, and that's gonna be 5/8. Okay, and this side is a little bit complicated, and let's see what we can do. We can use, maybe easier to use a circle. Okay, and a circle, I don't want to snap to any other sketch, so I'm gonna hide this first. I'll have to raise my voice. Okay, hide this, and circle. Well, a circle from the midpoint out to the top. I hope they will match each other, and let's trim away. Wow, it's gonna be complicated. Okay, I'll just pick this line, delete this, trim this away, trim that away, also trim this. Okay, so dimension from this arc to the center of the orange, it's gonna be 17/32. This is down, and okay, I think this shape is pretty much done. Right? If you want to constrain this, just put the dimension there, and we can put another yeah, that's pretty much all we need. And for this little box, I think still it's better to offset, so I don't have to draw that circle again. Again, the thickness is 3/32. That's 3/32. So pick the same single curve. Okay, click OK. That's our inside, and just make that thing sticking out a little bit. There's no dimension on the sketch for this, so that means the distance really doesn't matter as long as you can make them sticking out. Okay, finish. That's our second sketch, and we can hide this. We need the other datum. So for the third section, okay, third section. Again, that's box. So, well, or we can make circles. Well, let's make box first. Box and a circle. That's a basic shape, and trim away. Okay, then also I want this point to be on that point. Close. There's a coincident constraint. Alright, dimension. Dimension is dimension radius 7/16, and this should be, you don't even need to input this 7/8, because it's double the size of this. Okay. Or what we can do is we can put P267 times 2. Okay. Enter. And make this center and put 0 here. And the center of this arc to the center of this orange. Alright, we have a problem. we need to move this orange. But when you build this sketch, you want the center to be on this curve actually. So what we can do, let's try, we can add a okay, we can draw first, we can draw a horizontal reference line. Okay, put this to reference and add another point here, intersection. And on curve. Hopefully this will work. Okay. No, this is not very good. Okay, let's try intersection. It's here, intersection. And sketch. Okay, that's the sketch. Intersection. Not very good. Okay, let me think. Maybe we need to ditch this sketch then. Ditch this. Build a new sketch. And the reference point. Or we go back, modify this. Okay, that's our problem. Alright, it seems like we have a big problem here. This direction is not right. So, okay, I guess this problem in this coordinate system. Alright, measure angle. I suppose you will not have the same problem as mine. Okay. And I think I can modify this. X point. Yeah, I see this point is not right. So X point is go to end point. This, okay. And that's gonna be another end point. End point. Okay. Okay, now they're matched. And let's have a look at the second datum. No, first datum is fine. Second datum. Yeah, second datum is fine too because it's on the absolute orange. Okay, and we're good on this. Height, and try to build a sketch here. Now it's on the curve. Okay. Very tiny mistake. Made everything mess. Okay. Alright. maybe we need to show this a little bit so get the orientation. Okay, and first box. Okay. Second, a circle on this side, and trim away, trim, close. And I want that to be coincident. You have coincident here, and coincident. So point to this point. Got it. Okay. Then dimension. Dimension is 7/8. Oh, it's pretty big. Okay. And this should be a half of this dimension. That's gonna be P27 divided by 2. Okay. This way, make sure everything's match each other. And lastly, we want the circle to be on x-axis, and you can see these two lines are fixed. And also this to the center of the circle is 13/32. Okay, and the center of the circle to the orange is 3/32. Now the whole thing is green, and it's good. And we can turn off this. And okay, next thing, as usual, offset. So we can offset this. Alright, click OK, and put a straight line here somewhere. Okay, now we can use Shift 8. Okay. Well, optimally you can, the outside of these three curve should be pretty much aligned. So here I'm gonna align to the here first. Well, it's interesting. It's all about the tilted coordinate system. Okay. So it's pretty far away. Anyway, just keep doing this. Boundary curve, this one, extend 2, and boundary curve, we'll close this, do that again, extend this 2, close. Okay, so now this sketch is reference on that one. We can have a look at the top. Yeah. They are aligned, close. We can go back and maybe put this line, okay, same as here. Not sure it's gonna move it. It's not gonna move. Well, it doesn't matter really. Should not be. Okay. 3 cross section. The next thing is the guidelines. So turn this on, and the guideline is gonna be on this y-x plane, or we can have this on that y-x plane. It actually doesn't matter. So we're gonna start sketch on this y-x. Okay, and we have two guidelines. Start the first. It's gonna be an arc, 3-point arc. So we want to choose a midpoint. Turn off the other stuff. Okay. So one midpoint, second midpoint. You want the bigger loop. Okay. And third midpoint. This is one. And here. Okay. First, I'm not sure if we can do this, but make sure that's what happened. First, we need a project curve from this sketch, so we can have an arc that's tangent to this arc. So we're gonna project this arc to our sketch. Okay, so for clear view, we can hide this original sketch and turn this to a reference. Now we use 3-point arc. Okay, and the start point again is gonna be the midpoint. Second, it's still midpoint, and okay, you want to make sure that's tangent. Okay, so we have the first arc, and the second arc is gonna be from here to that point. Also, you want to make sure this is tangent to the first arc. And we're done with this two guideline. We can click finish. So here is we're ready for the swept. Okay. Now let's do it. Swept. First cross section. You want to pick the same spot. Add another set, the same spot, add the third set, same spot. So the first swept is going to be the outside of the metal, and the guideline. Okay, first guideline, and we can add another set, maybe second guideline. Alright, so if you look at here, it's kind of weird. And we can turn on the okay. This we need to use by point. So right away, it's much better. Okay, and we want a smooth surface. So cubic. This should give us a very smooth surface, and click OK. So 3 cross section, 2 guideline, and cubic by points, which is all on the slides. Okay. Now let's swap the inside part. Okay, let's do another swap, and now we're gonna pick this. Okay, and another set. Pick the smaller loop, and another set, smaller loop. Now we pick the guideline. It's gonna be the same as the outside shape. One guideline, a new set, another guideline. Okay, and also cubic by point. Let's have a look. Okay, click OK. Now we don't cut it right now because we need this gonna cut into the grip actually. So, but for your, you can check if this is right and wrong. So we can do is within this thinks there's no boolean here. Okay, we just use boolean. Subject, target is gonna be the bigger one. Tool is gonna be the smaller one. Click OK. And you can have a look at the shape, if they're smooth or not, and the thickness, if there are anything sticking out. Okay, if everything is good, we just go back because we're gonna cut later. Keep this. Okay, so we're done with the jaw and well, let me show everything first. Control A. Okay, so we're done on the top part. So next we're gonna go ahead and do the grip. So that's gonna be in part 2. Okay, and let's stop here.